So my name is Marco, and I'm all that's left between you and your lunch. So I'll try to not be longer than the time allotted. So I've been a Microsoft MVP for quite a long time. When I was first awarded, I was in the ASP.NET and IIS category. Now this has been rebranded into Visual Studio and Development Technologies, which sounds huge, very, very broad, but I'm very focused on anything that's web. And I've been running container-based applications for working with containers for the last 3 years, approximately. And this is basically going to be the core topic of the talk today. So just by a chance, how many of you have had the chance to play with Docker at least once? Okay, no worries for the other guys. We start from scratch, so you will be able to follow the talk in any case. So what are we going to talk about? We're going to start with trying to understand what's Docker and why it matters for us as developers, even though it smells like something which is very, very DevOps-oriented. And then we're going to see what are the options that we have in order to run an ASP.NETCore application onto Docker. Now, this will take pretty much 7 minutes of my talk. The rest of the remainder of the time will be spent in grabbing an existing application, porting it into Docker, and eventually deploying it to AKS in Azure. The time is quite short today, but I'll try to do the best I can. Okay, sounds good? Great. So let's set some context first. So how did we get here? When I started working on IT almost 20 years ago, we used to have all these application server, DB server, web server, and so forth and so on. And the main reason why we wanted to have all these pieces of hardware was isolation. So we didn't want that upgrading one application could jeopardize the stability of another application if they were sharing the same running environment. So in that sense, the advent of virtual machines has represented a great breakthrough in terms of technology, and it's perfectly valid. I mean, the entire Azure runs on virtual machines. But what is the problem with that model? Well, the problem is obviously the thumbprint, the weight of the operating system that, since the virtual machines virtualize hardware, we have to install onto each of them, which obviously represents a waste of resources and slows down our boot and shutdown operations. So how does the container model change the game here? Well, we don't virtualize the hardware anymore. We have something which is the container engine, all right? And on this container engine is capable of running some artifacts like these ones, which look pretty much like virtual machines. We can stop them, we can restart them, we can delete them, but they are much more lighter, okay? So we don't have the burden of installing the entire operating system onto them. And how is that possible? It is possible because if virtual machines virtualize the hardware, containers virtualize the operating system. Or better say, that they virtualize the kernel of the operating system, which means that any process running in a container sits in his virtual file system, process tree, virtual network, and so forth and so on. All right, so they are isolated. Obviously, since we virtualize an operating system, we have to make a choice up front. So we need to decide whether we want to virtualize Linux or Windows. And this is basically what is the meaning of when you hear Linux containers or Windows containers. How does the flow work? Well, at the starting point, we have an image, all right, which sits somewhere in the registry, which could be on the cloud, in your local network, and so forth and so on. And this image, you can think about it like the template of the virtual machine or like a class in C#. All right, so we write the definition of a class, and then through Docker CLI, which is a command line interface we use to send commands to the Docker engine, we can create a container, which is a running instance of an image. And we will see that this parallelism between an image and a class is not completely out of place here, because there's a sort of inheritance with images as well. Docker, as the engine, has been around for almost 6 years now. It's free and open source. You can use it for commercial products. There is an enterprise edition that adds some services on top of it, but yeah, it's the de facto standard, even though it's not the only platform, but it's the standard to run container-based application nowadays. Now, done with the slides, let's try to have a look at Docker in action. So, one of the components that gets installed on my machine when I install Docker is obviously the Docker CLI, which is the client, because Docker is a client-server system, all right? And as you can see here, my client says that it's running. My server says, the client says that it's running on Windows, whereas the server is running on a Linux machine. Now, how's that possible? Well, it is possible because Docker installs a very lightweight virtual machine, which we can use to run Linux container. This is not the only option. We can run Linux containers natively in Windows as well, thanks to the Linux subsystem for Windows, but it's not 100% compatible, so I'd recommend to stick with the virtual machine solution for the beginning. Obviously, this is only needed because I'm using a Windows laptop. If I was using a Linux laptop, I wouldn't need that. But the most interesting part of Docker is not sitting on my machine. It's a website called the Docker Hub, which you can think about as a sort of an app store for us developers. So here you can see hundreds of thousands of images you can download and use for experimenting with software. So let's make a very quick example of this. So let's imagine that we want to run WordPress, all right? There is an image for WordPress on the Docker Hub. So if I go here, back on my machine, I can just type docker run WordPress. And since WordPress is a website, I want to remap its port 80 on my port 8080 on my localhost. Okay? As soon as I hit this, as you can see, Docker says that it's not capable of finding the WordPress image on my machine, so it's going to the Docker Hub, downloading some stuff, and one thing that we can see here, we can appreciate, is that an image is just a set of layers, all right, which are immutable, read-only, which means that if for some reasons I already happen to have some of these layers on my machine because they are shared with some other images, I don't have to download them again. Okay, now WordPress is running. I can go to my browser, go to localhost 8080, and as you can see, there is a WordPress on my machine. I didn't have to install PHP, anything like that, all right? And if I do docker ps, I can see that effectively there is a container called Quizzical Mendeleev. The namings are quite interesting, which has been generated. I can stop it by typing docker stop 96C. I just have to type the first few bits of the ID of the container, and now that WordPress is stopped, I hit F5 and I get an error. I can now restart it with docker start, and can you see how fast it is to stop and start a container compared to a virtual machine? Now WordPress is back online. As soon as I've done experimenting with it, I do a docker rm. Since this is still in execution, I need to force it, and I type the same ID, and now WordPress is not running anymore on my machine. It's completely stopped. But I still have, if I do docker images, I still have my WordPress image stored locally. So the next time I want to run it, I don't have to re-download it again. Okay? So this is a really interesting way of deploying applications. And I can't wait to apply this to some custom application that I've built here for you. So what is the application we're going to play with today? It's this one. So it's a two-tier application. It's not the typical Hello World, but it's also something a bit more complex, something that allows you to reuse some of the concepts for even systems which are more complicated, like dozens of microservices. And it has a front end and a back end. They're both written in ASP.NETCore, and we see on the front end Web API. They're using Redis and Mongo, and we want to use Nginx as a reverse proxy because we don't want to expose Kestrel directly onto the internet. What is that the application does? It's just a list of people I can create, delete, and so forth and so on. So I've already created the project here in Visual Studio, and what I'd like to do is, first of all, port it to Docker. Why is that? Because I'd like to be able to distribute it in the same way as we did with WordPress, all right? So someone else can do Docker run and can run it straight away in his machine or in his server without having to care about which version of .NET Core I was using, whether the SDK, the runtime is there, and so forth and so on, all right? Now, Visual Studio offers a few options to do that. All I have to do is right-clicking here on the project and select Add. And as you can see, I have the possibility, if I can manage to move this away, I have the possibility of, I'm getting there, of either adding a simple Docker support. This is useful if I had a single product or a single project, or adding a container orchestration support, which we will see in a second, allows me to run multiple projects at the same time, the entire system at the same time. So here I can choose whichever container orchestrator I want to use. I select the Docker Compose. I can select the operating system. This is because I'm using a .NET Core. If I was using the .NET Framework, full framework, I could only have selected Windows. And as soon as I do that, Visual Studio takes care of plumbing the support for Docker on my project, which is this Docker file list of statements in a Docker file which will instruct Docker how to create an image out of my project. I can do the same here for the front end. So I add the container orchestration support, Docker Compose, and I'm good to go now. Okay? Now, if we go back to the console for 1 second, and let me clean this up for you, and we do a Docker PS to list which containers are in execution, as you can see, Visual Studio has already created 2 containers for my front end and back end, which are already running on my machine. So I can go here, hit F5, and in a second we will be able to see our application running with Visual Studio, even without even knowing that actually Docker is there in the background. So my front end is running, for example, in port 32783. Let's go here, 32783. And as you can see, my application is there. I can click About, and I've set a breakpoint here. The breakpoint has been hit. Now, it doesn't look like it's running in a container, all right? But it actually is. So if you can see, the operating system that I'm using is Unix, okay? So it's effectively running on something which is not my host machine anymore, all right? But Visual Studio does everything it can in order to make sure that my experience as a developer is not touched, is not impacted by that. Even though it's not trivial. I mean, it had to install the remote debugger on the container, and it had to wire up the connection to it, okay? But for me, everything looks the same. I can even go here and modify, for example, one of these files, so, and type something like this. I save it, and I go back in my home page, and in a second, we will be able to see that, yeah, the change is there, okay? We didn't have to rebuild the machine, the project. Everything is already there. In order to do that, Visual Studio shares a portion of our file system with Docker so that any changes that we make in the source code is immediately reflected in the running container without having to rebuild the image for that container. Now, this all looks cool, but I still need those Redis and Mongo that I had as a pre-requirements here on my applications. Now, I could go and do a bunch of Docker runs to run Redis and Mongo. It's funny because, for example, there isn't a way to actually run Redis in a Windows operating system. Okay, there isn't an installer for it, but thanks to container, I could do that. But I can do something even better than this. As part of me adding support for Docker to these projects, do you remember that I've selected that Docker Compose option? This is basically allowed Visual Studio to create a Docker Compose project here on my solution, which is basically a list of all the components of my system. Now, it has just the back end and the front end at the minute, but nothing prevents me to go here and say, you know what, I want a Compose Demo Redis, Compose Demo DB, sorry, service whose image is Mongo. And I also want a Compose Demo Redis image, container, sorry, whose image is Redis. And how do I connect to these items, to these containers, once my application is running? Well, Docker Composer ensures you that the name of the service that you set here will be the host name for that service. So I can basically go here on my application where I have the settings for Mongo, and I can select to connect to Compose Demo DB. And I can do the same here on the front end, setting the connection string for Redis. And here, instead of a localhost blah, blah, blah for the backend, I can just simply connect to the backend, because that is the name of the service which has been set here. All right? Now, are you guessing where we're heading? What I wanted is that at the press of F5, everything runs. Now, I'm very, very tempted to press that F5, but I want to do one step further here. If you remember, we also had Nginx here in the equation. So what I want to do is being able to add Nginx as well. And in order to do that, I can't simply add an Nginx image, because this needs to be configured. So I need to create a custom image out of it, which we can call web server, for example. And this image will be built out of a Docker file, which is this one that I'm going to show you. It's incredibly simple. It's just a, where is it? Nginx. Here you go. It's just create an image out of Nginx. This is the concept of inheritance that I was mentioning before, and copy a configuration file to the folder within the container where this configuration is expected by the reverse proxy. And how does the configuration look like? It's also very, very simple. It's basically just listen to port 80, and if you receive anything, just forward the call to the front end. All right? So let me now try to see if all that we built actually works. But in the meantime that Visual Studio spins up the containers for me, let's think about the impact for this for us developers. So we are able to test any type of containers, products, etc., without risking to jeopardize the stability of our machines. But secondly, think about a new developer joining your team. So, I mean, I don't know what your experience looks like, but for me, new guys just spend the first week by installing stuff. All right? Here, this Docker Compose file, which hopefully works. Let me do a Docker PS. Oh yeah, I forgot to add something here. I want to also modify the Docker Compose file to say that we want to expose the port 80 of Nginx on my port 8080, and we also want to say that Nginx, this web server, depends on the availability of the front end, because otherwise Nginx would just flag that route as unavailable and return a 502. So let me this is front end. There's a typo. Control F5, now it should run. So think about the impact of this. This goes under source control. So someone joins our team, he does just a git pull, git clone, and is up and running. So I think that this is incredibly cool and productive. And it's really a way to that we revolutionize the way we run a container, we run applications, and we run our software development practice. Is it running now? There might be some typo somewhere. Let me try to restart Visual Studio. Yeah, now it's building all of our containers. If I go here, I should see all the containers running now, and hopefully we will be able to run it. Yeah, it's there. We made it. So I can create a new person, I can do stuff, and everything works. Okay? So let's think about what we achieved here. We've installed, we've run Nginx, Redis, Mongo without having to install anything, and we use them as dependencies of our application in an extremely seamless way. All right? So who likes it? I do. Great. That's a good percentage. Yeah. Awesome. Great. So now I have my images, and I could potentially just start distributing them with my front end and my back end to my consumers. Unfortunately, these two images are marked as dev for a reason. They have all the artifacts and tricks in them, which Visual Studio uses to ensure that development experience that we were looking at before, but they are not actually ready to be distributed. All right, they are empty shells because they rely on the code being on my machine. In order to build something which is effectively something we can release, all I have to do is go in here, switch my debug mode to release, my compile mode to release, and I just need to kick off a build. Now, this one will take a bunch of time, so it's a good moment to go back 1 second to the slides and try to understand what's in that Docker file that we had a glimpse of before, which are basically the mean that Visual Studio uses to create those artifacts that we will be distributing in a second. So, what is this Docker file? A Docker file, what we want to do is basically building an image out of my project, all right? But since those images are going to be distributed over the internet, I also want that those images are not that big, okay? I want small images so that downloads are very quick. At the same time, in order to build my application, I need the entire SDK. Okay, it turns out that the runtime that it's needed to run my code is just above 200 megabytes, whereas the full SDK is pretty much 2 gigabytes. Okay, so hence the reason of such a complicated, it looks like complicated, we will see in a second that it's not, Dockerfile, which is basically using multiple images. It's like a sort of multiple inheritance, okay? I don't know how many of you are former C++ developers or current C++, great, okay? In which we are using several existing images to build our final artifact, okay? So what do we do here in this Dockerfile? Let's have a look at the first 3 lines. We are creating an image that we call base, which inherits from Microsoft.com/.NET Core ASP.NET 2.2. So this is the runtime for ASP.NET Core. It contains anything that is needed to run ASP.NET Core. Then we expose port 80, and we also have created a /app folder, an empty one. Okay, this is the portion that is run in debug mode. Okay, when we switched to release, Visual Studio started doing some other stuff. So it creates a second image. This is a functionality called multi-staged build in Docker, which allows us to use different images. So it creates a second image, which is called build, and this one inherits from the full SDK. Okay, so it's very big, 2 gigabytes. Now, let's pretend that this gray area here is my local machine, and these are the images. So the next steps are about creating a work directory called source and copying my csproj files. Okay? And then it runs .NET restore, which means that also the packages get restored on that base, in that build image. The next step is a copy ... What the heck does it mean? So the first argument is my localhost, okay? So, and the second argument is the current directory in the image, okay? So what I'm basically doing here, I'm copying the entire directory of source code that I have on my local machine onto this image. And then I do a .NET build selecting /app as the output for my application. Okay? Next step, Visual Studio creates a third image called publish, which inherits from build. Okay, so it has anything that is in here. And here we do a .NET publish release to /app. So this will precompile your Razor view, will minify your CSS, JavaScript, and blah, blah, blah. And if any of you have done at least one publish from Visual Studio in your life, you will understand that basically what ends up here on this folder is everything that is needed for my application to run. The runtime is around it, and here we have all our custom components. Fourth step, Visual Studio creates a fourth image called final, which inherits from base. So this is a small one, okay? And here, what we do is that we copy the content of /app in publish, this one, onto here. And then the last step is entry point.NET backend DLL. So this is basically what needs to be run when I do docker run backend. We just run .NET backend DLL, which will spin up Kestrel and basically put my application alive. All right, and this is the final image we are ready to distribute. So if we go back to the console now, and I do a Docker images, as you can see now, I have my backend and front-end image, which are images which are marked as latest. This is the conventional tag for Docker to highlight the latest version of something. Okay, so these are images we can distribute. And how do we do that? Well, distributing an image means uploading it onto a registry. And a registry could be the Docker Hub, for example, or if you're using Azure, it could be something like a service called Azure Container Registry. You can think about Azure Container Registry like your private registry on Azure. And it's well integrated with the rest of the Azure ecosystem, even though it's fully compatible with Docker. So it supports, for example, authentication via Azure Active Directory, so you can restrict which processes, which systems, or which users have access to read from that registry or write images on or upload images to that registry. It's also a service made in the Azure way, so you can, for example, geo-replicate it where your servers are, so that this will, in order to slow down the downloads between the registry and the servers that will run your software. And again, it's fully compatible. There are a set of instructions I can run on Docker to connect to the registry and push images onto it. But most likely, you want to use something automated. You expect to do a git commit, git push, and see some sort of a build pipeline to kick off and eventually create an image and upload it into that registry. And I've provided you an example on how to do it here on Azure DevOps. And the nice part of it is that it only requires 2 simple steps. Because at the end of the day, the entire build phase is running within Docker through that Docker file that we just saw. So all we have to do here is having a first step that builds the Docker file that we've seen before. Okay, and the second step is going to push that image that the first step has created onto the Docker registry. And as you can see, this step, this task in Azure DevOps is also very well integrated with Azure. So I didn't have to configure any permissions, even though this repository is not publicly available. I didn't have to configure any permissions. So Azure DevOps does the marshalling of anything that is security related for me. So it assigns the permissions to the security principal under which the agent is running in order to be able to connect to my registry. All right. One thing I want also to mention is that I most likely want to keep a history of all the images that I built, all right, so that I can switch between versions quite easily. I don't want to just have a latest, because then I don't know what that latest is anymore after the 3rd or 4th release. And so what I've done here is, the bare minimum, what we can do is tagging that image with something that changes every time. For example, the build ID. I agree with you, it's not very semantic, but it's a first option that we have. This is the most simple option that we have. What happens then is that as soon as I run my builds, I end up with having my front end, for example, repository here in the Azure Container Registry with all the images that I pushed in that way. And here, in order to run one of these, I just have to click here on the ellipsis and select whether I want to run it on a Azure Container instance or deploy it to a web app. Okay, so I could do that. But does it smell right? So let's think about a complex architecture with dozens of microservices. Do we really want to go and right-click here for each of them and deploy them somewhere? Actually, we need something more powerful. What I'd like to do is having something similar to the Docker Compose file in which I describe my system and boom, it runs. So basically, we need an orchestrator. Okay, what is an orchestrator? An orchestrator is a software that receives a manifest that describes how my application looks like and takes care of running it over time and keeping it healthy. Kubernetes is one of the most famous orchestrators out there. Another one is Service Fabric, for example. And it's basically a cluster of virtual machines called agent nodes that are capable of running a workload expressed in terms of containers, or better said, pods. Now, don't get annoyed. I mean, I appreciate that there's a lot of new terminology here. Let's pretend, for the sake of this talk, that a pod is like a container. It's not actually like that, but so please don't say it outside of this room that I told you that a pod is like a container. But let's pretend that they are the same thing for the sake of this talk. All right. So we can deploy these pods over these agent nodes. But the nice thing about an orchestrator, about Kubernetes, is that I don't do it directly. I don't assign pod A to worker node 1. I only talk with a special type of node called master node. I interact with it with a command line interface pretty much similar to the Docker CLI that we saw. Okay, this one is called kubectl or kubectl. And then it's the master node responsibility to understand which of these nodes are capable of running that workload and spreading the load across all of them. Okay? Now, Kubernetes is made by Google. It has been donated by Google to the open source community, and it has one of the most active open source community around ever worldwide. All right, and Microsoft is also a strong contributor of Kubernetes itself. It's free to use, so you can just go install it on your local cluster of virtual machines or hardware. But it is a bit painful. I'll be honest with you. It is a bit painful to install it and keep it healthy over time. So, for example, if there's a security patch that gets released, you have to gracefully remove a node, wait for all the workload to be moved to some other node, and then you can upgrade it and reinstall it. So it's a bit painful. How many of you had the pleasure of installing Kubernetes by hand? How was it? Okay. Okay. Now, the nice thing is that in Azure, we have a service called Azure Kubernetes Service, which is a managed version of Kubernetes, which means that I can go here onto the portal and click Create a Resource. I select Kubernetes, and I then specify, as usual, the resource group, the subscription location, geographical location, which version of Kubernetes I want to run, how many virtual machines. I can set up the security, networking, so forth and so on. And in 5 minutes' time, you have a brand new shiny Kubernetes cluster. Okay. This is not the only good news. So once you have that cluster, you can easily go here and perform operations that would take way more time if you were doing it on your own hardware, like scaling it, upgrading it to the newest version. Plus, there are some fancy add-ons for monitoring and to ease the development process. Also, you only happen to pay for the agent nodes, so for the virtual machines that perform the workload. So you don't even see the master node. You talk to it, but it's completely managed by Azure, updated, and we don't have to care about aspects such as reliability or high availability of this agent of this master node. All right, we don't even pay for it. So how do I work with Kubernetes? The easiest way is by command line. Now, in order to work with it, you can use Azure CLI. I'm running Azure CLI within a container. So here, as you can see, I've done docker start -i interactive, and I'm running this container Azure CLI 3, in which I've installed the Azure CLI, which is already connected to my subscription. Why did I do that? Well, because it has been a bit painful in the past to upgrade and update the Azure CLI. Also, if you have multiple subscriptions to target, it's not always easy to switch between one and the other. So if we have containers, that's a nice trick that you can use. And I can do AZ AKS, and here I have a bunch of options. So I can select install CLI, for example, and install kubectl on, in this case, on this container, but you can install it on your machine, obviously. Or you can do get credentials, pass the resource group name and the name of your cluster, and this will automatically wire up the connectivity between this environment and the container on the cloud. Once this is there, you can do things such as kubectl get nodes, for example. And as you can see, my cluster, for example, has 3 nodes running here. All right? How do we deploy code to it? Well, as I told you, we're going to use a file, a manifest file that describes my system. So don't get scared about it. We will delve a bit deeper on it in a minute. But as you can see, you can recognize some familiar components here. You can see our backend. Oh, everything is deployed in the namespace, so we can keep multiple applications isolated, even though they're sharing the same cluster. So you can see the backend, the front end, my web server, for example. What you don't see are MongoDB or Redis. And why is that? Well, because, actually, you can run things like a database on a Kubernetes cluster. If you look at the MongoDB documentation, this is supported, and there is a page that describes on how to manage it once it's installed in Kubernetes. But do we really want to do that? Think about, I don't know, finding a DBA who is skilled in MongoDB and knows Kubernetes. That's the unicorn. Right? So since we're in Azure, why don't we do something like this? Okay, in which I run my stateless containers in the cluster, but I also interact with some of the PaaS services available in Azure, like Cosmos DB and Azure Redis Cache. Okay, so that's the reason why I don't have my database and cache containers pods in my file. And if we are using Azure DevOps, I can easily build a release pipeline that allows me to do a one-click deployment here. Let's see if I can open it. Like this one. Okay, let's look at how it's basically set up. So here I'm accepting all my artifacts, like my front end, back end, web server, plus something that contains my provisioning scripts. And what it means is that I can, for example, select I can create a release and select which versions of my images I want to deploy. And as soon as I hit create, this guy is going to run a bunch of steps. So in these steps here, I'm going to create those services in an Azure resource group. I'm running an ARM template to automatically spin up Cosmos DB and Redis Cache. And then I'm running, eventually, I'm doing a kubectl apply, and I'm passing a file which is exactly the one I was showing you before. Now, this will take 1 minute to complete, so it's good to go back 1 second to the slides and try to understand what's in that file. This is a snippet I've taken from there, and as you can see, at the very bottom of it, I'm specifying how my pod looks like. So I'm saying that I want to create a pod which I call front end, which contains an image, runs an image which is front end latest, for example, and it's exposed on port 80. I don't create that pod directly. I create it within a bigger object, which is called Replica Set. Thanks to the Replica Set, I can specify that, for example, I want 3 replicas of my pod. Now, what the Replica Set does is, apart from obviously creating those 3 instances, it also spin up spins up a process in the background that constantly monitors for my pod availability. Should one of them crash for any reason, the replica set will immediately kick off and spin up a new one so that the actual state of the cluster matches the declared state of my manifest, and the world is a happy place. I don't even create a replica set directly. I create it within an outer object called deployment. And this deployment allows me to do fancy things such as roll updates, rollbacks. I can control how the existing pods get replaced by new versions and so forth and so on. Now, with this snippet of code, I end up with these 3 pods. Each of them has its own network identity. So how can I refer to them? I need another object, which is called service. Think about a service like a load balancer, in which I'm specifying a host name, for example, front-end service, and also a selector. Here I'm selecting all the pods who have a label app whose value is front-end. And this is exactly what I've specified here on the replica set. Now, this uses a very similar monitoring background process to monitor the availability of these pods, so that if one of them is down, it gets cordoned from the load balancer and it doesn't receive any traffic. So my application stays healthy. All right. Obviously, then the replica set will just crash it, delete it, and create a new one. So now I should have given enough time to Kubernetes to deploy all my stuff. I can do a kubectl get service, and I'm looking at the namespace staging, which is where my application is running. And my application, as you can see, has this IP address. There's a service called web server, which has a public IP address that I can try to hit, and hopefully there will be my application here. Oops, beers. Oh, nice. It will be my application here running. This time is running on Kubernetes with Cosmos DB and Redis cache. Not every service by default is only visible within the cluster, so it's not exposed on the public internet, all right? Unless you specify, like I did here, that a service is of type of load balancer. In this case, that service gets provided by, so Kubernetes will spin up a public IP within Azure and will assign it to that service so that we can reach it. It's not the only way to expose something. It's probably the simplest one to show. There are other more evolved way of doing that, like ingress controllers, but that's one of the solutions you can adopt. Last thing I want to show you is the Kubernetes dashboard. You can connect to your Kubernetes dashboard by clicking, by typing kubectl proxy, and I need to whitelist all the addresses here, and then you can connect to a nasty URL which is in the slide deck, so you will be able to see it. Now, this is not exposed on the public internet. With kubectl proxy, what I've done is that I've created a tunnel from my laptop towards my Kubernetes cluster in Azure. And as you can see, I'm connecting to localhost thanks to that tunnel. And here I can have, at a glance, I can see which containers, which nodes are available. I can switch to the various namespaces that I have, for example, staging. And within staging, I can look at the pods running on my cluster. I can click here on the front end, and I can even see the logs for this pod. Do they sound familiar? These are just the ASP.NETCore logs, all right? I can go back here onto the deployments. For example, I can see my front-end deployment. If I click on it, I can even scale it and say, okay, now I want 5 instances of my front end. As soon as I click OK, I go back to the pods. And as you can see, there are already 2 pods being created, 2 more pods being created to accommodate my request. F5, they should already be there. I go into one of them. I can delete it. And now there's another one being created because the replica set kicked in. The current state of the cluster 4 was different than the declared state on my manifest, so it spins up a new one, which is now here. Okay, and the same happens if your application crashes for any reason, for example, because it runs out of memory. Automatically, the replica set will sanitize the runtime of your system. Cool. I think that the time is over. So let me just recap quickly what we've done. We managed to Dockerize the front end and back end, add Nginx, and run them together with Mongo Redis on my machine without installing pretty much anything on my machine apart from Docker. We saved the images in Azure Container Registry through a CI pipeline, and then we used a release definition to push our system in its entirety in Azure Kubernetes Service, and we even managed to have a look at the dashboard. This is a recap of pretty much all the commands that I used during the talk. Some links to the documentation about the stuff that we've seen, and yeah, this is it. If you have any questions, just feel free to ask or to get in touch by email or on Twitter.